I would like to share a slightly different way of looking at the algebraic operation we just went through. Look at the right side of our previous equation. Tree age is equal to sample years multiplied by tree radius divided by sample length. When we count the number of years contained within our wood sample, represented by SY, and divide that by the length of our sample, represented by SL, we have a ratio of SY over SL. Considering the units of that proportion, we have years per inch. In other words, we have a proportion showing the average number of years of the tree's life, represented by 1 inch of the wood sample. Once we multiply SY over SL by TR, or the tree radius, we are actually multiplying those units of years per inch by inches in our tree radius. Years per inch times number of inches. Those inch units cancel, and we're left with years. And in this way, we've determined the age of the tree. By the way, in terms of units, the inverse of SY over SL results in units of inches per year, which can be thought of as a tree growth rate of sorts. In other words, how much fatter is the tree getting, in inches, with each passing year? Again, this is not a new way of determining tree age. It is simply another way of looking at the variables and measurements we have collected. I also want to point out that, especially for large trees, the exercise we just went through only provides an estimation of a tree's age. If we have not reached the pith, we cannot guarantee complete accuracy. For very large trees, when the sample we've obtained via the increment borer is a relatively small proportion of the tree radius, we introduce a source of error. Regardless, this exercise provides a way for you to estimate the age of any tree using some very basic algebra.